Hello friends, today we are going to discuss about sensor interface with Arduino. So we are going to interface ultrasonic sensor, then LDR, and after that temperature sensor, and then LCD interface. So how we can do interfacing, you can see over here. So first we are just interfacing ultrasonic sensor. So ultrasonic sensor has this specification of ultrasonic sensor and how it will work. You can see over here, when any ultrasonic wave transmitted from over here, then it strike on the object, then received over here. This one is trigger and this one is echo, and distance is calculated, that is time into speed of sound in the air, and divide by 2. Then we are going to interface LDR sensor. LDR is light dependent sensor. So how you can interface LDR, that is very easy to implement. So for interfacing LDR sensor, we have to make voltage divider circuit over here, and this one is LDR, and after that we have to get output from over here. That output used to go to analog pin in the microcontroller, and then we can read variable voltage that is being converted from register, variable register, and when light fall on the register, this LDR, as light is increasing, the resistance value is decreasing. Then after that we are going to interface temperature sensor, that is TMP35, and after that we are going to interface LCD. So these all these sensors and their sensor value we are going to display on the LCD. How we can do that without having any kind of hardware? So we are going to simulate all these things in the Tinkercad. So let's move towards Tinkercad. So in Tinkercad, what we have to do, we have to create new project, open the circuit. In Tinkercad, first we have to do sign up, and after doing sign up we have to go to circuit. In the circuit, what we have to do, create new project. In create new project, first we have to interface sensor, and then we have to move ahead. So for interfacing sensor, we have to take first Arduino from the components, and we have to drag and drop over here. Then after that we have to take one breadboard. In breadboard we have to interface one LDR we can found over here, and then we have to connect one resistor as voltage divider circuit. We are going to make over here, rotate component from over here. Yes, rotate it. Now we have to connect supply also. This one should be connected with 5 volt. This one should be connected with ground. Yes, and this one is signal part. Signal should be connected with A0. My circuit is ready. Now I am going to make a code. You can make LDR code in a simple way. With graphical, you can read analog value, like go to output, input, and then read analog pin, and then after that at output you can print it serially, and you can display over here. Now you can run it, start simulation, and then you can serially check the value of analog sensor that is connected with A0 pin over here. Value 6 is coming. Now after that make it fit to screen, and then increase LDR light. As I am increasing light intensity, value of analog is increasing. Analog sensor in Arduino microcontroller, analog pin read value in the format of 10 bit, that is 1023 from 0 to 1023. Okay, now we can put any kind of condition over here. This is all about LDR sensor interface with Arduino. And what is the exact code, embedded C code over here, that you can see pin mode, input, serial begin, serial print, analog, A0, whatever we are going to read. Then what we have to do, we have to go to circuit, and now we are going to interface LCD also. For LCD, what we have to do, we have to take LCD, search over here LCD, and we have to take it now LCD. So what connection we have to do for the LCD, that is very important. So I'm going to see over here, you can see in LCD these are connections, like first one pin should be connected with ground, second one should be connected with 5 volt, then this one is connected with potentiometer, this one is contrast control, this one RS pin should be connected with 12 number pin, this one should be ground, and then this one should be 11. These are pin diagram. These pin are for controlling their brightness, their light, impact light. So now all these connections I'm going to make in the Tinkercad like this. So let's see how it work. So I'm going to integrate LCD first, then I will come up with LDR. So I'm going to delete it first. So first we are going to connect ground with ground. This one is ground, and then 5 volt with 5 volt. This one 5 volt. Yes. Now I have to make connection of LCD. So LCD ground should be connected with ground. This one is power 5 volt. Yes. Then third terminal connection is contrast. This should be connected with potentiometer. So potentiometer we have to take from over here. We can connect potentiometer like this. This one should be connected with 5 volt. This one is output. This output should goes to 3 number. Yes. And this one should goes to ground. Yes. So I made the connection of potentiometer. Then this pin register select value, this pin goes to pin number 13. Sorry, pin number 12. And then after that this number pin goes to ground, and again this enable pin goes to 11 number pin. Okay, now I'm going to connect all other pins. So this one LED cathode should be connected with ground, and one resistor should be connected over here in between other pins, that is 15 number pin should be connected with resistor. So I'm going to use one resistor over here with 5 volt. Okay, anyway I can connect. This one should be connected with resistor, and this one should be connected with 5 volt. Yes. Sorry. Then what we have to do after making connection, now this one pin goes to 2 number pin. 2 number pin of the arduino. And then this one pin goes to 3 number pin. And then this number pin goes to 4 number pin. Yes. And again next pin goes to 5 number pin. You can make connection according to your convenience. Yes, so I made all the connection, and now what we have to do, we have to put code over here. So over here we can't make graphical code because there are limited blocks in the Tinkercad. So for that, what we have to do, we have to use one library over here, and we have to use this code, as well as we have to insert one library. For that we have to move to text mode. So over there we can write any code. So first what we have to do, we have to insert one library. Library is over here, liquid crystal library, include it. Yes, now we have to write 1, 2, 3 more syntax of liquid crystal library. So what are these syntax that I have shown over here in the program? Liquid crystal LCD. So this line we have to write over there, then we will able to make it. Liquid crystal in same format, liquid crystal, and then we have to define pin, which pin we are using. So 12 pin, 11 pin, and then after that 5, 4, 3, 2. Yes, these pins we are using. Then after that we have to go to over here, serial begin is already defined in setup. In setup we have to initialize LCD. Let's see in which format it is. LCD.begin. LCD.begin in small. LCD.begin to initialize that library, and after making it LCD.begin, then we have to write over here 16 into 2 dimension of LCD dot 2. That is, we have written over here 16 comma 2, not dot, we have to use only comma. Okay, and after doing it, my LCD setup part is ready. Now we are going to print it. For printing we have to write it LCD dot print, then whatever we want to print, that we can print in double quote, like weight skill e-learning. Okay, so after doing it, you have to put semicolon. So in loop, what we want to print, in loop we have to do, so earlier code is also available for analog pin. So over there I'm just going to change LCD cursor, set cursor. This one is command for LCD set cursor. You can see over here, LCD dot set cursor, C should be capital and 0, 1. So how we can do that? LCD set S should be capital, set cursor C also should be capital, S should be small, C should be capital, C should be capital. Okay, set cursor, so cursor should be at 0 and 1, mean column 1 row 2. So after doing it, now we have changed the LCD cursor position. Now we can print LCD dot print. We can print any sensor value that we are doing it over serial. So we can print it same value whatever we have written over here. So we can replace it with this. So in print, in LCD we no need to write ln. Ln stands for new line. Yes. Now it's ready to print on the LCD at this position. So whatever value we will read on analog pin, it is being get printed on this position, and then we can take some delay of 100 seconds so that we can visualize it, see it. Now check it out, that code is okay or not. Is there any mistake or is it working? For that we have to simulate it. So there is some mistake. So what is that mistake? We have to check it out. Void setup, there is some mistake is saying void setup is started. Input, okay. This one LCD dot begin. Let's see LCD dot begin is small 16 into 2. Then LCD dot print liquid crystal LCD, that we have to write liquid crystal LCD. So I'm going to liquid crystal liquid crystal LCD. Yes, so we have written it, put it properly. Yes, so after that what we have to do, check it again. Again this error is coming. A note liquid crystal, where is A note? Liquid crystal was not declared in the scope. Expected primary expression before token. So over here we have to put semicolon. Yes, this one is okay. Yes, we have put it semicolon also. Serial was not declared in the serial dot print. Serial dot begin is declared. Serial dot print LCD dot print. Yes, it is okay. And before AL, expected before A1, expected semicolon. So it's showing some error, that we have to check what error is coming. So if you face any error over here, what you have to do, you have to copy it and open in Arduino, so that you can identify that what error is coming over there. So liquid crystal is over here in our code, liquid crystal CRYSTL. You have to check all the spelling. So I'm going to open some recent LCD code. So this one code is liquid crystal LCD 12. Okay, I'm going to check my code that I have prepared over there, copy and paste it, then verify it and check it what error is coming, so that you can properly verify it over here. Now it's done compiled over here. So what you have to do, you have to check proper formatting. Tool, formatting, include, edit, yes, tool, here, help, yes, everything is fine. Yes, so now again verify it and put it over there. So my code is okay. Go again over there, and now you have to check, delete it and paste your code and then run it, close it. Yes, now it is working. Okay, so your code is now working, but there you cannot see over here in the screen that some value is not being printed, so we have to increase that value. Yes, now you can see this value is coming over here, analog read, but it's continuously increasing, so we have to check it out. Because LCD, after printing it, LCD should be get clear. So how it can be done? LCD dot clear, yes, and then it is being done. And and we are going to put it over here. So if it will get clear should be 0, 1. Let's see it's working or not. LCD dot clear 0, 1. Okay, it's showing some error, so we have to vacant it, then run it. Okay, now LCD is clear. Changing value over here. Yes, now value is coming, so you can see analog value is changing and coming. So new value is coming every time. And also if you want to display that whatever you have written above, that also you have to print it, so that each time it can be get reprinted. Yes, now it is also being get reprinted. Now it's skill e-learning, and this one, these are the value. So we have not connected anything at analog pin, that's why it's showing some error. Now what we have to do, we have to connect one LDR, because we are making code for the LDR sensor. So LDR, we have to connect one resistor. Same circuit we have to make over here. So I'm rotating resistor. Yes. Now after that you have to connect it with ground, and this one should be connected with 5 volt. Yes, and this terminal is goes to output. Output is A0. Yes. Now my circuit is ready. Now I will get exact value like 6 I am getting. So I can increase or decrease light brightness. The value is increasing or decreasing. So if we want to display that, value should be displayed in the format of light intensity. So I will replace it light intensity. Spelling you can check. Okay, so I'm running it. Now you can see light intensity is 6, and now I'm increasing it. Yes, it's changing continuously as per my light available on the LDR. So whatever sensor value we want to display on the LCD, that can be done over here in a simple way. If we are going to use it only one, we don't want to clear LCD, then some error can become, because again and again value is being written over there. Yes, so one more I have to remove. Light intensity I have written over here. These are syntax you have to just understand, so that you can make it. Okay, you know its skill value is coming. As I'm increasing value is increasing. Again I'm going to 6, but upcoming the other value is not changing, because they are not is being erased. So that can be done like this. This one is code, you can write it. Now you can deploy it in your project. Directly copy from over here and then open your Arduino and delete it, paste it and verify it, and then you can upload this code on your Arduino. Done. Yes, now you can upload it in your Arduino. Now I'm going to change this LDR with other sensor like temperature sensor. So for that, what you have to do, you have to use temperature sensor. So I'm going to delete it. So you can delete from over here. deleted. Let me check what error is coming. Yes. So you can refresh it over here. If it is not working, then it will start working properly and your project is being get saved on the cloud. So after getting refreshed, you can delete it again, and now I'm going to replace it with temperature sensor. So you can, if you have deleted by mistakenly, then you can redo it. Yes, now I'm going to use temperature sensor, and value of temperature sensor get displayed over here. TEMP. This one sensor I'm just taking. So this sensor I can put over here. How this sensor is working, you can see in this sensor we have to connect like this. First number pin should be connected with 5 volt, second number pin is analog output, and third one is ground. So this connection we have to make on the Arduino. So first one should be connected with 5 volt, so 5 volt is over here, and second should be connected with ground. Ground is also available over here, and then third one is signal, that is analog input. So that I'm just going to connect with A0. So code will be same, just we have to multiply one thing, that is your multiplication factor of this temperature sensor. So what is that multiplication factor, that also you can do. So how you can check that multiplication factor, I'm just checking it. Copy this code in your project anywhere, and then go to text and blocks, continue, and over here there is some input temperature sensor analog value. So you can convert this block and check it, their value, block plus text. This one is a conversion factor. So you can take one variable, create variable AA, and then AA should set to analog value. Yes. So this one is analog read of that temperature. So this one is conversion factor. So what you have to do, you have to multiply this A minus 40 plus 0.485 into analog read minus 20. This one is a conversion for this sensor, temperature sensor. So how we can use this? So I'm just going to in text, continue. Okay, this one code AA we have taken, and that code I'm just going to put over here again. Setup part should be in setup. So above setup, this part should be put it over here on upper part, and then after that what we have to do, we have to go to setup part. Setup things should be in setup. Pin mode A note is input already defined, and then we have to go to loop. In loop, these are things we have to put. So serial print we don't want to print, these values just we want to print. So after that we have to put enter, set cursor and value. What value? AA value we want to print. Replace this analog A0 with AA. AA is variable over there, we are storing temperature. So now we are going to print that value on the LCD. So let's print it. Let's see how it is working. Yes, now you can see temperature is displayed over here, and you can change that temperature value Yes, it's coming in minus, plus. With the temperature I'm just changing over here. You can see over here I'm just changing the temperature. Similar way temperature is being displayed over here. This minus value, same minus value we are getting it below. Yes. So similar way we can display temperature value over here. So if we want to display any other sensor, that also we can use air quality sensor similar way. So that also we can implement, and we can replace, and we can use any kind of sensor in our project, and that value can be displayed on the LCD. Thank you so much for watching. Kindly like and subscribe on the YouTube channel so that you can get more and more updates.